Hi, how's it going? My name is Carl Diaz. I'm with the Learning Resources Center here at the University of Colorado, Denver, and today we're going to be talking about kind of two things here. We're going to speak about specific gravity for a second, but really just look at how to use Archimedes' principle for an object that's floating. This looks a lot like specific gravity, but they're not quite the same thing, but they kind of are. So I just want to make sure you guys understand that. So first, let's just start with specific gravity. First, know what specific gravity is if we're asked, if you're asked, what's the specific gravity of an object? You're being asked the ratio of that object's density, whatever object they're asking you, to the density of water at this specific temperature. The reason that specific temperature is because water is the most dense, has the maximum density at atmospheric pressure at that temperature. So it gives us a good idea of the best look at this ratio. And so specific gravity is really just the ratio of the object to the ratio of the density of the object to the density of water. But that number, that water number, will always be this 1,000 because it's specific to this. So really what you need to know is just the specific gravity is the density of the object over this 1,000 kilogram per meter cubed, or the density of water at that temperature. That's getting you specific gravity. Again, it's the ratio of the object's density to the density of water. So coming over here, right, how can we kind of use that same idea, but we want to talk about it a little bit different, in terms of looking at how an object is floating in a fluid. So first of all, we know Archimedes' principle tells us that the density of the object and the volume of an object is equal to the density of the fluid that it's in times the volume of fluid that it's in. So really what this ratio is telling us a lot about weight. We could write this in terms of weight, but the way that I have it written here is that what we're saying is that for a fully submerged object, that the amount of the volume of the object in the fluid is going to be equal to the amount of volume of fluid displaced, is really what this equation is trying to tell us. We could also look at it as weight. We can turn density and volume into mass. And multiply both sides by g and really look at the weight in the same way. But we'll just describe it from this way because this is how we kind of use it. And so using Archimedes' principle, even when an object isn't fully submerged, I know when we said when it's fully submerged, the volume of the object is equal to the full volume of fluid displaced. They'll be equal. The total amount of volume of the object will be equal to the amount of fluid that it's displaced. We can still use that idea to look at a floating object, because when we rearrange this equation, we get, first of all, this important ratio over here, which is if we take the idea that we were looking at, that this is the volume of the object in the fluid and this is the volume of fluid displaced by that object, and we make a ratio out of it, which is really, we're just bringing the density of fluid under the density of the object and the volume of the object into the volume of fluids. These are just kind of swapping places, and we get this equation. We see that when we do that, we get this ratio, which is a fraction of the object's volume that's submerged. It's really telling us the volume of the object submerged, or the ratio of the volume of how much of the volume of the object is in the fluid to the volume of fluid that's being displaced. So it's giving us that ratio, and we see that ratio is also equal to just the difference in the densities, right? The density of the object to the density of the fluid. So rather than know this, it's a lot easier sometimes just to know the densities of the objects we're talking about. So what we can do is we can use this ratio, this density of the object over the density of fluid, to kind of figure out how much of an object is floating in a fluid, because we know that this ratio right here is going to be equal to the fraction of the object's volume that's submerged. Is pretty much what this fractions tell us. So keep that in mind. Since we know this is what we're looking for, but it's equal to this, we can just use the densities of the fluid. So we know that the density of the object over the density of the fluid, when we divide it, is going to be equal to the percentage of the object in the fluid. And you'll see what I mean here. Now keep in mind that this ratio right here, as in all ratios, are based off of 1. So when we multiply, or when we do this division, we're going to get a decimal number, or if we start doing whole numbers, we want to understand what that means too. So when we get a full whole number, when this equals 1, that means that the object's fully submerged right underneath the surface. But if this is larger than 1, 2, 3, the object's deeper and deeper in the fluid, okay? But keep in mind that this ratio is based off of 1. So if you reach 1, what that means is we'd multiply that by 100, which means 100% of the object is in the fluid is what's happening there, and that's what we do here. So let's say, I just gave a couple examples here so that you can kind of see what to do, but for this first one, let's say that we have a ratio that gets us 0.9. The density of the object to the density of the fluid. We put it in our calculator, we just divide those two numbers, and we get 0.90. Well, we know when we multiply that by 100, we're going to get a percentage, and that percentage is telling us how much is inside the fluid, how much of the object's inside the fluid. So that first number you get when you do the ratio is how much of the object is in the fluid, or how much of the object is submerged, okay? But since you know this ratio, and this ratio is based off of 100, you subtract 90 from 100 and you get 10%, right? That's, well, you get 10, and right, it'd be 10% since these are percentages we're subtracting. And that's how much is going to be outside of the fluid, all right? So how can you use those numbers? Well, let's say they give you a question that tells you have an object that's 10 meters, right, long, and this is the numbers that you get when they give you the densities of the objects in the fluid, and you get these numbers. Well, how can you use that? They say, well, how much, you got a 10-meter object, how much of it is actually inside the fluid? Well, if 90% of it's in the fluid, what you can do now, you don't want to use that 90%, I mean, you could, but you want to just go backwards. So make sure that you're using this 0.90. So you want to take the length of the object, so in this case it's 10 meters, right? And we're multiplying it times that number that we got from this fraction, which is again how much is inside the fluid. And when we do that, we get 9, which is, or 9 meters in this case, where that meters is going to be how much, that's actually how much of the object is in the fluid. And if you know that, again, if it's 10 meters long, you can subtract that from 10 meters and know that 1 meter of the object is outside the fluid, or you can do the math, multiply this, it'd be 0.0 times 10 and do that, okay? And then just another example, if you do this ratio and you get 0.45, right, you want to multiply that by 100, which means 45% of the object would be inside the fluid or submerged, or 55% of the object would be outside the fluid. Again, you'll be given these numbers, the density of the object, the density of the fluid. You just divide them. Whatever numbers you get next, that's how much, when you multiply that by 100, that's how much of a percentage of the object is in the fluid. If you take that number and subtract it from 100, you're going to get how much of the object is outside of the fluid. You can use those numbers if you know the length of the object. You can multiply these numbers by the length of the object to get how much is actually in or out of the fluid. All right, does that make sense? Hopefully this was helpful. I know it was short, quick, and sweet, but that's what it was supposed to be. Hopefully you took something away from this. Don't forget specific gravity is something different. We ask you specific gravity. This is what we're asking you to do, but we can also use that ratio to do other things. All right, thank you so much for watching. Hope this was helpful, and I'll see you on the next video.